Hello everyone, I hope I am audible. I welcome you all to the GRE Preparation Made Easy Quantitative Reasoning class by Ms. Zabita Ban. Instructions for the participants: make sure you have a stable internet connection and a noise-free environment. We recommend you to use the earphones for best experience. Also respect your instructor, your classmates and yourself. Be respectful and professional. Do not write anything inappropriate on the chat box. We have three packages, that is bronze, silver and gold. If you're grade 2 silver and gold, you will get extra benefits like evaluated mock tests, expert university recommendations and so on. You can contact us. Also, we have free profile evaluation, comprehensive evaluation, university shortlisting, post recommendations, recommendation reports and doubt clearance with our experts. We also have free live IELTS classes, that is from Monday to Friday, 7:30 to 8:30 p.m. It is a 4-week course. I have added the link on the chat box to join the Telegram channel. Also, we have free Duolingo classes, Monday to Friday. It starts from 6:30 to 7:30 p.m. It is a 2-week course. Also, we have this webinar this Saturday. It is Study Abroad Loan Masterclass by IDFC Bank. It is a live session with IDFC manager. You will get one-on-one spot evaluation, discount processing fees, and low interest. You can register through this link. Also, we have the special offers that starts from ₹499 with extra benefits if you want to upgrade to the gold package. And here are a few achievements. Thank you. This is the website. When you go on, you can select the country, course and specialization. When you go on explore, you can select the country, university, courses and exams. You will get all the information from here. When you go on solution, information regarding admission, free evaluation, talk to the counselor, test preparation, store additional services. Also, weekly blogs are uploaded. You can go through them. Also, to contact us, here are all the details. So you can WhatsApp us, call us and mail us. Also, for the event, this is the event. It is on 14th October, 7 p.m. to 8 p.m. Also, when you go on my test preparation from here and you click over here on the GRE, and here you'll get the handouts and the recordings. When you go on data and here, so there's the handout. So thank you. Also, in case of any query, you can write it on the chat box. And ma'am, I hand it over to you. You can begin with today's session.
Thank you and good evening and all here. Today's session is regarding permutations, counting permutations and combinations. I hope my voice is clear. And I'm just sharing my screen. Today's session we are dealing with counting permutations and combinations. Yeah. So before going with the presentation, I would like to explain a little basic stuff here regarding the counting, permutation, and combination. So starting with the counting. So what does it mean by counting? So counting, where we use this counting, where we use permutations, and what is the necessity of using all this? So this is the thing you should know first. So the questions related to counting, like counting the numbers or anything, it may be the question may be, but you should know the logic, you should know the technique, and you should know how the formulas are related to this. Basically, there are some formulas you should remember, very small formulas, no need to go in depth in that. I'll give you some logic stuff to remember and understand this counting, permutation, and combination concept. So first of all, talking about the counting. So fundamentals of counting are of two types of fundamentals are there for counting. We can say it as two types of principles are there for counting. First thing is multiplication. fundamental principles of multiplication, and another thing will be for principles of addition. Multiplication and addition. Let us say if there are two jobs. If there are two jobs, one of them can be completed in m ways. If there are two jobs, one can complete in n ways and another can complete in n ways. In how many ways the two jobs can be done? In how many ways the two jobs can be done, then we can say that it's m into n. So this is related to multiplication. So I repeat once again, let us say if there are two jobs, one job can be completed in m ways and another job can be completed in n ways. In how many ways the total number of, how many total number of ways are there in which the jobs can be completed? That can be done by multiplying, right? And one more thing, one small example. Let us say there are 10 girls in the class and 8 boys in the class. Let us say there are 10 girls and 8 boys in the class. The teacher need to select one girl and one boy. In how many ways the teacher can select one girl and one boy from 10 girls and 8 boys? I'm waiting for your answer in the chat box. Quick answer, quick reply in the chat box. Yeah. At the end of the session, I'll suggest the links to revise the basic stuff and all. Please wait. Yeah. Answer for this. Anybody? If there are 10 girls and 8 boys in a class, okay, the teacher need to select one girl and one boy. In how many ways she can select? In how many ways the selection can be done? As I told you before, the selection can be done in the form of 10 into 8. Right? 10 into 8. So that is 80 ways the teacher can select students from a class. Now, principles of addition. How do we deal with this addition principle? The same concept. But here a small change. So let us say if there are two jobs, okay, one job can be completed independently. Two jobs which are independently done. One job can be completed in m ways, and another job can be completed in n ways, respectively. Then either of the two jobs can be performed in m plus n ways. Either of the two jobs can be performed in m plus n ways. Either of the two jobs. Either of the two jobs. Now, two jobs, okay, can be completed in m plus n ways. For example, let us say there are 10 girls and 8 boys in a class. The teacher need to select one girl or one boy. One girl or one boy. So in how many ways she can select? From the 10 girls and 8 boys. So teacher need to select 10 girls or one girl or one boy, right? So one girl from 10 girls and one boy from 8 boys. So in how many ways can be done? M plus n ways. So that can be done in the form of m is 10, n is 8. 10 plus 8 ways the teacher can select. That is 18 ways the teacher can select. Okay. So relating these two, a little trick to understand and remember. Whenever and is there, whenever there is a word called and which is relating two sentences is related by n, then we will multiply. Whenever the two sentences are relating with r, then we will add. So the fundamental basic stuff or principles related to this counting depends on and r. And means multiplication, r means addition. The stuff will be helpful for you in probability also. I think previously in probability concept also I have explained the same thing. Okay. Now, let's see some number based question. Let us say some number is given. A question is given, right? Like how many 3-digit numbers can you form? How many 3-digit numbers are 3-digit integers? How many 3-digit integers are there in which no number appear more than once? I repeat the question. How many 3-digit integers are there in which no number appears more than once? How many 3-digit integers are there? Where the condition here is number should not appear more than once. No number should appear more than once. Any answer? So, how can you represent this is we need a 3-digit number, so make 3 spaces in this way. You need to fill your 3-digit number in all these 3 spaces. So, how many numbers are there? 1-digit numbers are. How many numbers I can put in each and every space? So, I can place any number from 0 to 9 in each and every space, right? From 0 to 9, there are how many numbers? 10 numbers, including 0 and 9 also. Okay, 0 and 9 consist of 10 numbers totally. So I want a number which is 3-digit number. I have to see how many numbers I can place in this first digit, in this first blank from 0 to 9. How many possible numbers are there I can place in this first blank is 9 possible numbers I can place, because if I put 0 here, the number will not become a 3-digit number, it will become 2-digit number. That's the reason I'm not taking all the 10, I'm excluding 0. Now in the second space I can put 0, so 10. In the third space I can put 0, here also 10, right? So multiplying all this stuff, then we can say that, wait a minute. So here there are 2 conditions. You can see the condition, number should not appear more than once. That means whatever the number you are taking, that number should not appear more than once. In the sense, repetition is not allowed. Okay, so whatever the stuff we have done before, that was for repetition allowed. But according to the question here, it says a number should not appear more than once. That's the reason whatever number we have placed before, that is not been repeating. For example, let us say the number should be unique for each and every, like 4, 5, 7. Okay, something like that. The number should not repeat. It should not be like 299. The number should not repeat. So here the first space I can place 9 digits. In second space I can place 9 here, because from 10 completely I have to exclude whatever the number I have placed in the first digit. So left with 9. Again with 10 digits I have to exclude. I have to deduct the numbers which I have placed in last 2 digits. So it will be 8. Now our answer will be in this way, 9 into 9 into 8. So 81 into 8, 648. 648 ways we can, our 648 numbers are there, which are 3-digit numbers, where the numbers are not appeared more than once. Okay. Yeah. I hope I'm clear with the concept here. If still you have any doubts, you can always put a message in the chat box. Okay. So this is the condition where the repetition is not allowed. So whenever no condition is there, repetition is allowed, then the same stuff here we can take anything, but the number should be 3-digit. So 9 here, and the rest of the things can be taken as all 10 can be included here, all 10 can included here, then it will be 900 digits will be there, which are 3-digit numbers, where the number should not, there is no condition given like repetition allowed. Okay, right. Next. So simple question for you guys. Let us say, what is a palindrome number? So what is palindrome number? What is a palindrome number or palindrome word? Anybody can put a message in the chat box waiting for your answer. Okay, right. The number which is read same from right to left and left to right. We call it as a palindrome. Okay. And now here, how many palindrome total number of 4-digit numbers will be there? Let me clear you the question. What is the total number of 4-digit palindrome numbers? How many total number of 4-digit palindrome numbers will be there? Palindrome numbers are there. Any answer? How many 4-digit palindrome numbers are there? 4-digit palindrome numbers. 4 digits palindrome number. So 4 spaces as usual. So numbers 0 to 9, I have to pick the numbers. Okay. So to become a palindrome number, the number should be read same from right to left and left to right. So how many numbers I can include here in the first space? so that it is suitable to the condition. I cannot include 0 because if you include 0, it will become 3-digit number. So I have to remove that. So 9 spaces, 9 numbers I can include here in the first space. In the second space, how many numbers we can put? 10 numbers we can include in the second space. Can you tell me what are the numbers I have to include in third space and fourth space? Quick reply in chat box. Reply quickly. I repeat once again, my question here is, so according to the basic stuff, whatever I have discussed before, the palindrome number we are going to be asked here. If it is a palindrome, 4-digit number, we take 4 spaces. In the first space, we cannot include 0, so 9 possibilities. In second space, 10 possibilities. In third space and fourth space, what is the possibilities? What will be the possibility? Same number in the sense, one possibility each. Exactly. Exact. So here in this, I can put only one because whatever the number I have taken here, the same number will be repeated here. Whatever the number I have taken here, the same number will be repeated here, right? So that's the thing. We have to take the same number here also. So only one possibility. Got it? So you multiply all the things, 9 into 10 into 1 into 1. It's nothing but 90 numbers. Okay, so this is a basic stuff regarding the counting concept. Okay, now let's go with the questions. Yeah, one more thing here. The figure here is, you can see the figure on the screen. The figure is showing that the routes. So imagine that there is a route map as shown below connecting cities A, B, and C. So there is a route map connecting cities A, B, and C. Now, if a person has to go from city A to city C, in how many different routes can be taken to complete the journey? So how many different routes he can take to complete the journey? First of all, let us see, from A to B, we have 3 routes. From city A to city B, we have 3 routes. You can see that in the figure, it's very clearly given. From city B to city C, we have 4 routes. From city B to city C, we have 4 routes. 1, 2, 3, 4, right? We have 4 routes. Now, how many routes, how many different routes a person can choose? A person can choose how many different routes. So it is nothing but we have to just take the product of this 3 into 4. That will be 12 different 3. This is 3. 3 into 4, that will be 12 different options. Okay, right. Now, there is a question here. Please go. Quick answer in the chat. There are 4 buses running between Hyderabad and Mumbai, 5 buses running between Mumbai to Bangalore, and 3 buses running between Hyderabad to Bangalore. How many different ways can a person take to reach Bangalore from Hyderabad? How many different ways are there? That has been asked here. Try to give me the answer for this. 4 ways from Hyderabad to Mumbai, 5 from Mumbai to Bangalore, and 3 from Hyderabad to Bangalore. 4, 5, and 3. Okay. Is my screen is not visible?
Ma'am, it's visible.
There was a message. Okay. Yes. So 4 into 5 into 3. So 4 into 5 into 3, 60 ways. Next question. An exam paper contains 6 multiple choice questions with 3 options for each question. If each question is necessarily attempted, find the number of different ways of answering the exam paper. Yes. We could reply in the chat box. Exam paper contains 6 multiple choice questions. 1, 2, 3, 4, 5, 6 multiple choice questions with 3 options each having 3 options. Okay, that means anything from the 3, anything from the 3, right? So each having 3 options. So 3, 3, 3, and 3. 3 options each. Now find the number of different ways of answering the exam paper. 3 into 3 into 3 into 3 into 3. Let me see the answer for this. No. 6 multiple choice questions with 3 options for each question. If each question is necessarily attempted, find the number of ways of answering the exam paper. Number of ways of answering the exam. Different ways is asked. Okay, number of different ways. Number of different ways from 3, anything it may be from 3, right? So it may be number 1 selected, it may be number 2 selected, it may be number 3 selected. So how many possibilities? 3 possibilities for answer the first question. How many possibilities to answer in the second question? 3 possibilities. How many possibilities here? 3. So anything among the 3 he can select, right? You should not do it addition here in between. So you have to understand the basic stuff here. What is the question saying? 6 multiple choice questions with 3 options. For example, if there are 3-digit number have to be taken from 0 to 5. So how many numbers I can put here? I cannot add it, right? So I have to take anything from 0 to 5. That how many possibilities? 6 possibilities. So 6 possibilities here. So 6 possibilities here. So 6 multiplying all this, you get answer. Okay, in the same way here also 3 options. This is the way we have to follow. Let me see. Is there any query? Yeah, it's not 18 ways. It's 3 into 3 into 3 into 3 into 3 into 3. That means 3 power 6. 729 ways. Right. Next question. Try to do this question here. A person is playing a game. He will roll a die. He will roll a die. And wait a minute. He will roll a die, and if he gets an odd number, he will toss a coin. If he gets an even number, when rolling the die, he will roll the die again. Find the total number of outcomes. I'll give you a hint to go with this. So first thing, how many possibilities are there if a if a die is rolled? If a die is rolled, how many possibilities are there? Obviously, there will be 6 possibilities, right? The dice will be having numbered 6 faces, 6 numbered of that. Okay, so 6 possibilities will be there if a die is rolled. If a coin is tossed, how many possibilities are there in the coin? If a coin is tossed, there will be 2 faces for a coin. Okay, 2 faces for a coin. So 2 possibilities if a coin is tossed. What are the conditions given? So we are not at all worried about if it is an even number or odd number, whatever it may be. But we have to see a die is rolled. How many possibilities? 1, 2, 3, 4, 5, and 6 possibilities. Among these, how many odd numbers are there? 1, 3, 5 odd numbers are there. And how many even numbers are there? 1, 2, 3 even numbers are there. Okay. So we are not worried of that. But we have to see whenever the outcome is odd, what he is doing, whenever the outcome is odd, he will toss a coin. So total, what we have to do, total outcome will be always number of outcomes from the rolling a die. Number of outcomes, whatever we are getting from rolling a die, into number of outcomes when a coin is tossed. Number of outcomes when a coin is tossed, number of outcomes from coin into finally what is the third concept here? Whenever it is even, the dice is rolled again. Whenever it is becoming an even, the dice is rolling again. So the number of outcomes from a dice. Okay. So number of outcomes from a dice is 6. Number of outcomes from a coin will be having 2 faces. So 2 and again 6. So 36 into 2, that will be 72 ways, 72 possibilities. The total number of possible outcomes in this game will be 72 possible outcomes. I hope you understood the question. If there is anything that you are unable to understand, please put a message in the chat box. I repeat once again. So here, what are the conditions given? Whenever the dice is rolled, we should know that the die will be having 6 possibilities, 6 faces. Okay. So whenever it is rolling, whenever it is an odd number, when the die is giving you an odd number, the person is tossing a coin. Then whenever it is giving you an even number, he is rolling a die. Then that means how many situations are happening? 3 situations. First thing is playing a game with a dice. Second thing is tossing a coin. And third thing is rolling a die. So that all the 3 combinedly we are putting in one frame, 6 into 2 into 6, that will be 17. Right? I hope you understood. Let's move to the next question. Next concept is regarding combinations, permutations and combinations. So combination is nothing but whatever the definition is there on the screen, that is correct. It's a grouping or subset of items. For a combination, the order does not matter, all that stuff. But here I would like to give you a simple concept regarding the permutations and combinations. Okay. Yeah. So permutation. Next concept here is permutations. So permutations is nothing but a number of ways a group of things can be arranged. A basic idea about the permutation is nothing but number of ways the group of things can be arranged. We call it as the permutations. For example, let us say there are 3 letters A, B, and C. In how many ways we can arrange A, B, and C? In how many ways we can arrange A, B, and C? That's my question. Anyone can answer for this. We can reply in chat. In how many ways I can arrange A, B, and C? 3 letters A, B, and C. Yes. Yes. So if whatever it may be letter, it may be word, it may be numbers, whatever it may be, the arrangement of that simple statement is given. For example, let us say there is a word called Rahul. In how many ways we can arrange this Rahul? In how many ways? So whatever it may be, how many letters are there in the word? 3 letters. So 3 factorial ways. How many letters here in this word Rahul? R-A-H-U-L contains how many letters? 5 letters. So it can be arranged in how many ways? 5 factorial ways. In the same way, if any combination of numbers are given, we will apply the counting concept. Whenever there is a combination of letters given, we will apply this arrangement thing. Then we will apply this factorial, 5 factorial ways. Okay, so 3 into 2 is 6. So A, B, C can be arranged in how many ways? 3 factorial ways. That is 6 ways. Okay. Now, if there is any word with the letter which is repeating in that, for example, let us say there is a word called laptop. In how many ways we can arrange this laptop? How many number of ways we can arrange the word laptop? Laptop can be arranged in how many ways? So how many letters are there? First of all, 1, 2, 3, 4, 5, 6 letters. So 6 factorial divided by, we have to see for the letters which are repeating. So how many letters are repeating here and here? 2 letters are repeating. So divided by 2 factorial ways. Okay. In how many ways we can arrange laptop? The answer for this will be 6 factorial divided by 2 factorial ways. So what is 6 factorial? 6 factorial is nothing but count of the letters in the number, and 2 factorial is nothing but count of the repeated letters in the number. Okay. I hope you understood. Now give me the answer for this. In how many ways we can arrange a word Mississippi? I'll just write it here. Mississippi. In how many ways a word Mississippi can be arranged? So as I have given you the basic stuff, in how many ways we can arrange is nothing but a count of letters factorial in how divided by, if there is any repeating is there, count of letters factorial divided by count of repeated letters. Waiting for your answer. Quickly answer for this. I'm putting the question again on this time. In how many ways this Mississippi can be arranged? Yes. So this Mississippi contains totally how many letters? 11 letters in this. So 11 factorial in our numerator divided by denominator contains multiple repeated letters. So how many i's? You can see I, 1 I here, 2 I, 3 I, and 4 I. 4 i's. So 4 factorial. How many s's? 1, 2, 3, 4 s are there. So 4 factorial again. How many p's are there? 2 p's are there. So 2 factorial again. By solving this, you'll get the answer. Okay. Right. This was the concept of permutations. Let's do with combination stuff. Combinations. Okay. So whenever we are talking about combination, we should always remember, as we remember for permutation, it is arrangement. The combination will be applicable for selection. Okay. So combination is nothing but selection, selecting something. We apply the combination, selection. Combination is nothing but selection. For example, let us say in how many ways we can select 4 people from 7 people. 4 people from 7 people. In how many ways we can select 4 people from 7 people? A simple formula to remember here in combinations part, that is n factorial by n minus r factorial into r factorial. This is a formula for combination, and one formula for permutation is n factorial by n minus r factorial. N factorial by n minus r factorial is a formula we are applying for combination, permutation, and this is for combination. So it will be NPR is equals to n factorial by n minus r factorial. NCR will be n factorial by n minus r factorial into r factorial. Now, what is n? What is r? N is nothing but the number of objects available, and r is nothing but the number of objects to be selected. This is for selection, and this is for availability, number of objects available. That is how many people available, 7 people. How many things we are selecting from the 7 people? We are selecting 4 people from the 7 people. So it's nothing but 7 minus 4 into 7 minus 4 factorial into 4 factorial. Okay. So to do this combination, a simple trick. So let us say it is 7C4, right? So 7C4, 7 factorial here actually. So 7 factorial, we need to split the 7 for 7 into 6 into 5 into 4 into 3 into 2 into 1. This long, right? So a simple thing. So you can just split the 7 up to only 4 digits, like 7 into 6 into 5 into 4. Rest of the things will get cancelled here. Okay? Divided by 4 into 3 into 2. 4 gets cancels. 3, 2, 6. Finally, that will be 35 ways. The 4 people can be selected from 7 people. Okay. If there is, if you are having any doubts, you can put a query in the chat box. Okay. Right. Next, the same thing has been explained here in the figure. NCR, n factorial by n minus r factorial into r factorial. Starting with the question here. First question. Look at the question, read the question carefully and try to answer it. Yeah, I'm putting the question on the screen. A man has 3 different suits, 4 different shirts, 2 different pair of socks, and 5 different pair of shoes. In how many ways can the man dress himself if he must wear 1 suit, 1 shirt, 1 pair of socks, and 1 pair of shoes? Okay. So first suit. How many suits are there? Three different suits are there. How many shirts are there? 4 different shirts are there. How many socks are there? Set of pairs of socks. 2 different sets. Shoes. 5 different pairs of shoes are there. In how many ways can the man dress himself if he must wear one suit? One suit from how many suits? 3 suits. So 3C1. From 4, how many shirts you have to wear? 1. So here also 1, here also. Finally, by calculating these values, you can always find the answer. So 3, 4, 2, and 5. So always remember NC1 is always N. NCN, NC1 will be always 1. And NCN will be always 1. Okay. Now answer for this. So what we have to do? Should we multiply or should we add? Should we follow the fundamental rule of addition or multiplication? Quickly reply in the chat box. If you are done with the answer, reply with the answer or reply with the question what I am asking. Should we multiply or add? What should we do here? You had solved it for 50%. Rest of the 50%. Yes. See, everything have to be wear, right? So you have to wear suit and shirt and socks and shoes. So you have to wear shirts, 3 possibilities. Suit first, 3 possibilities. Shirt, 4 possibilities. Socks, 2 possibilities, and shoes, 5 possibilities. And is nothing but multiplication. Multiply all the stuff, you will get 120 ways. Okay, this will be the answer. Moving to the next concept here. Combination, second question. Let us say in a group of 6 boys and 4 girls, 4 children are to be selected. In how many different ways the selection can be done? A group of 6 boys and 4 girls. 4 children are to be selected. We should not add Sai to mark for the previous question. We should not add. We have to mark. Yeah. In a group of 6 boys and 4 girls, 4 children are to be selected. In how many different ways can they be selected? So 6 boys and 4 girls. In the sense, how many children are there totally? So the selection have to made from the total number of children, not the variation of gender. Is there any condition given here, right? So it is like at least 1 girl should be present, at least 2 boys should be present. If such a condition is there, we need to work. But here there is no such a condition given. The simple straightforward question: if there are 6 boys and 4 girls are there, 4 children are to be selected. In how many different ways they can be selected? So it's nothing but total 6 plus 4 is nothing but 10. The total number of children are 10. So here, how many children, how many selected group of children will be there in a selection? 4, so 4. 10C4. So as I told you before, split the number only 4 times. 10 into 9 into 8 into 7 divided by 4 into 3 into 2 into 1. So 2, 4 and 2 gets cancelled here, and 3 and 3. So 30 into 7, that will be 210. Next question. Question looks scary, but the answer is very easy. The process already we have done here. So it's like an Italian restaurant which has 320 distinct pasta dishes. Distinct is nothing but different. Okay, distinct pasta dishes. Each dish contains exactly 1 pasta, 1 meat and 1 sauce. If there are 8 pastas and 4 meats available, how many pastas are there? We choose it. Yes. 320 different pastas dishes. So total how many dishes are there? 320 dishes are there. So the dish contains 1 pasta, 1 meat and 1 sauce. Okay, 1 pasta, 1 meat and 1 sauce. P and M and yes. So here 8 pastas, so 8, 4 meats, 4 and sauces. We want to multiply all the stuff and try to find out the missing value. So 8 into 4, 320 is equals to 32 into S. So S will be with. Okay. So we have to be choosing from 10. Yes, it's 10. Next. The class contains 5 girls and 3 boys, and class has decided to form a group of 3. How many different groups can be formed such that the first question is no condition? There is no condition. Second question is at least 2 boys are there, and third question is there are more number of girls than boys in a group. Okay. So expecting answer from you for the first bit. A class contains 5 girls and 3 boys, and class has decided to form a group of 3. How many different groups can be formed such that there is no condition? How many different groups can be formed? We can't say. There is no condition. First of all, you see how many total number of students are there in the class. Required. Availability and requirement. We have to see only 2 things. Whatever are available and what do we require. So what is available here? 8 students are there. So 8 from 8 group have to be formed. That is 3 students group have to be formed. So 8C3. Okay, 8C3. 8C3 is nothing but 8 into 7 into 6 divided by 3 into 2. So you will just cancel up this part and it will be 7 into 8. 56. Okay, next question. Next question here. Second, there are at least 2 boys in a group. So at least 2 boys should be there in a group. So first of all, what is the condition here? How many total number of students? 8. So total students are 8. So how many students need to be required to form a group? A group should contain 3 students. What is the condition here? At least 2 boys should be there in a group. At least 2 boys. That means the group should contain at least 2 boys and 1 girl. 2 boys. At least 2 boys or 1 girl, not and here. It will be R. 2 boys or 1 girl. 2 boys, 1 girl gives you a group. At least we are just assuming, right? So it may be 2 girls and 1 boy. The 2 boys are 1 girl. Right? Just confusion because of this. Give me a second. Yeah. A group should contain at least 2 boys. A group should contain total 3 students. It should be at least 2 boys or 1 girl. And it should be, there is another way, it may be all 3 boys. There are 2 ways we have to assume here. The first way is the group should contain at least 2 boys or 1 girl, and all boys may be all the students may be boys. Okay, so from how many total 8C2 are in the sense addition, and what are the number of girls here? Not 8C2. How many boys are there? From boys we have to select. Boys are 3. 3C2 plus 5C1 and is multiplication 3C3. 3C3. Okay, by solving this, we'll get the answer. So 3C2. So as I told you, it will be 3 into 2 divided by 2. 2 gets cancelled here. 5C1 is always 5 and it's 1 here. So obviously it will be 3 plus 5, that is 8 ways. Okay, right. Moving to the next question here. Next topic is permutations. The last question, you can do it as your practice part. Permutations. Yes. I hope you are understanding the concepts. If there is any doubt, anything you are unable to understand, you can just put a query in the chat box. Okay, next. Permutation, we already explained the concept. So permutation is nothing but we will use that permutation for arrangement. So permutation, where we are using the permutation, we will not see the order. So we will see the order actually. Order matters here when we will talk about the permutations. When we talk about the combinations, order does not matter. Okay, number of ways of setting an arrangement of orders, arrangement of whatever items given in the question, that we will do with the concept here, the formula which is already discussed, NPR. So NCR will be taken for the combination part. NPR is n factorial by n minus r factorial. NCR is n factorial by n minus r factorial into r factorial. Where order does not matter in combination and order matters in combinations. Okay, right. First question. So 5 students in the classroom are lining up, one behind the other for recess. How many different lines are possible? How many different lines are possible whenever there are 5 students in a class? I have already told you to arrange anything that is nothing but the number of whatever the number it is, that number factorial. So 5 students are there in a classroom. So 5 factorial ways. The answer is simple. 5 factorial ways. So 5 factorial is 5 into 4 into 3 into 2 into 1. And so if you do that, 20, 60 and 120. 120. Okay. So if you want, you can even check this. So for the first position, it will be 5 ways. For the second position, it will be 4 ways. In this way, if you move on for the last position, and that means for the final position, if you see the 5th position here, 5, 4, 3, 2, 1 in this way also, the last one require 1 way. It can be done in 1 way. So multiplying all this together gives you 120 ways. Okay. The best thing to reply here, to remember here the stuff is only by the factorial ways. So whatever the numbers or whatever the letters to be arranged, so that can be done by that number of words factorial if it is done with the words also. Second question, how many 5-digit numbers can be formed using the digits 5, 6, 7, 8, 9 and 0? So there are some digits given, 5, 6, 7, 8, 9 are given. Okay, if no digit can be repeated, so there is a condition that repetition is not allowed. So numbers are 5, 6, 7, 8, 9 and 0. What is the type of number we need? We need a number of 5 digits. Okay, quickly answer for this in the chat. Let's see how much I have understood. And wait for your answer, take some time, try to finish it. Always, it's recommended to make a pattern like this. So 5 numbers, 5 spaces. And you have to check how many numbers can be suitable to fill up the blanks. Yes. So the number should be a 5-digit number. We cannot include 0 here in the first space. Then how many numbers I can put in the first space? How many possibilities? 1, 2, 3, 4 and 5. 5 possibilities are there. 5 possibilities to be filled in the first space, first blank. Second blank, how many possibilities? Second blank, we can include 0 here. Then second blank is 6 possibilities in the second blank. but the number of digits can be repeated. It's given that then if the no digit can be repeated. So repetition is not allowed. We cannot repeat the letters. Then how many numbers are possible to place here in the second digit? Again, so one number already done from 6. Okay, so how many possibilities here? We can include 0, so 5 possibilities. So here it is 4, here it is 3, and here it is 2. 5 into 5 factorial. Okay, so that's if you multiply all these values, you get the answer. Right? The answer? Yeah, it's 600. Correct. 600. Yeah, 600 days. Yeah. Right. Moving to the next question here. Yes. A state issues automobile license plates using 2 letters selected from 26 letter alphabet as well as 4 numerals, that is 4 numbers selected from the 0 to 10. Repeats are permitted. For example, so this is a simple example of the number actually, the license plate. Yes. So on the screen again. Yeah, you can see here the question says, what are the given data? You just write it on the paper so that it will be easy to you to remember. So a state issues automobile license plates using 2 letters. So 2 letters from 26 letter alphabets. Okay. As well as 4 numbers. 4 numbers from how many numbers totally? 0 to 9 numbers. So 10. 4 numbers are to be selected from 10 numbers. Okay. Total how many possibilities here? 36. So total number of things which can be there in this complete number, complete license plate. So it will be like license plate using 2 digits and 4 digits totally. So 1, 2, 3, 4, 5, 6. 4 numbers should be there and 2 letters should be there. Okay. So first space. How many possibilities? How many possibilities are there to put the number which is suitable for the data given above? So here it should be a number here. Okay. It should be a number. It should be letter. Rest of the things will be letters. Letters should be there and 2 numbers should be there. Is it so? So 2 letters. 2 letters should be there. 2 letters. And rest of the things should be 2 letters are to be selected from 26 letters. Yeah, 2 letters and 4 numbers. So 4 numbers and 2 letters. Okay, how many possibilities here? How many possibilities in the second space, third space, fourth space, fifth space, sixth space? Yeah, it's nothing but there is nothing given here. Repetition is allowed. Repetition is permitted. Whenever repetition is permitted, we need not to worry of that. It may be anything. It may be anything from 36, 36, 36, 36, 36, and 36. We can take anything from this complete 36. So the number of possibilities here is 36. So final answer will be 36 to the power 6. This will be the final answer. Okay, whenever repetition of the numbers or letters, the stuff is given which is allowed, then we need not to worry of the data. What will be the combination of letters? What will be the combination of numbers and all? So generally, we will take it as it is. So 6 times it is been repeating. So 36 to the power 6. The final answer will be 36 to the power 6. Okay, so it depends on the option. given. Sometimes a numerical entry question will be given, the box followed by the question. Directly you will type the answer in that. I hope you are understanding. Okay. Next. So let's rest of the question also the same thing. We will do this. Last question. So here the question is the same question which is related to the above, but the number repetition is not allowed. So previous one was repetition allowed, now it is repetition not allowed. If repetition is not allowed, then we should be very cautious while picking the numbers. We should go through all the conditions, whatever given. So repetition is not allowed. Okay, license plate requires one number, just one number should be there, one number, and rest of the things should be 4 letters, one number. So here there should be a number, rest of the things should be 4 letters, 1, 2, 3, and 4 letters, 1, 2, 3, and 4 letters. Selected from 20 letters. So here number of letters have been decreased. So letters are how many letters? 20 letters. Okay, numbers, how many numbers? 10 numbers. 0 is also, we have to include 0 also. So total, how many possibilities here if you see? So it will be total 30 possibilities. So first thing, in the first space, how many possibilities are there to pick a number from 0 to 10? It may be anything. 0 can be also be here. We can put a number 0 before, right? So because we will have 10 possibilities, we will put 10 here. In the second space, how many possibilities to become a letter? To choose a letter in the second space, repetition is not allowed. So repeated number should not be there here. So in the second space, in the third space, fourth space, and fifth space. So repeats are, wait a minute, repeats are permitted, but 4 letters of combination that is not allowed to be appear on license plate. Okay. I misunderstood the question. Repeats are allowed. Repeats are permitted here. Okay, let's see. If repetition is not allowed, how the question will be have to be assumed. So overall 20, right? So we will take 20 here. So 19 here, 18 here, and 17 here. If repetition is not allowed. If repeats are allowed, then finally it will be 10 into 20 into 20 into 20 into 20. So that will be 10 into 20 to the power 4. Will be the answer for repetition allowed, and this will be the answer for repetition not allowed. So you have to just multiply the stuff here, 10 into 20 into 19 into 18 into 17, and you'll get the answer. Okay. Now moving on to the one more condition. We are not at done still. So there is one 4-letter combination that is not allowed. One 4-letter combination is not allowed, that we have to subtract from this complete part. One 4-letter combination is not allowed. A 4-letter word has to be suffixed, right? A 4-letter word has to be suffixed with the digits, and that can be between 0 and 9. The digits can be 0 and 9. So 10 possibilities are such a thing will be there. So minus 10. This will be the final answer. Okay. So here we are done with that. If there is any doubt regarding this, you can put a message in the chat. Okay. So this was the last question for the day today. We are running out of time. If you have any doubts, I'll wait for 2 more minutes. If anybody want me to, yeah. Ma'am, in first 2 spaces, we should fill only 2 letters, right? In first 2 spaces. For which one? Yeah. You read the question properly from end to end, so you can understand. Okay, you can understand it. It's not a big deal. Okay, right. So this is all for the day today. If still you have any doubts, you can put a message in the chat box. If not, I'll quit the list.
Thank you, ma'am. Also, if anyone has any doubt, you can write it on the chat box. And don't forget to register for the upcoming event, which is on Saturday. Ma'am, Himani is asking for the basic revision link.
Yeah, you can purchase a book like from the ETS official guide. GRE official guide. If you want, you can purchase. Even there are some additions are there in Google also. You can download, but it will be previous additions. If you want current addition, you have to purchase it. GRE official guide. Okay, thank you.
Thank you, ma'am, and I hope that was helpful. Also, you all may please leave the class. Thank you.